Normally, aromatase enzyme is responsible for conversion of androstenedione to estrone. Estrone is converted to estradiol by an enzyme called 17-cis-hydroxysteroid dehydrogenase type 1, and the enzyme 17-cis-hydroxysteroid dehydrogenase type 2 inactivates estrogen. Normal endometrium, in response to progesterone, has elevated levels of 17-cis-hydroxysteroid dehydrogenase type 2, which antagonizes the estrogen effects in normal endometrium during the luteal phase. Progesterone represses matrix metalloproteinases activity. Matrix metalloproteinases is a group of collagenases implicated in endometrial turnover during normal menstruation. The steroidogenic cascade is a complex series of enzymatic reactions that occur in the mitochondria and endoplasmic reticulum of steroidogenic cells to produce steroid hormones like estradiol. Steroidogenesis begins in the theca cells where cholesterol is converted to androgens and is completed by granulosa cells that convert androgens to estrogens. The interplay between estrogen receptors alpha and beta and progesterone receptors is a complex and fascinating dance in the symphony of female physiology. Estrogen receptors alpha are primarily expressed in reproductive tissues like the uterus and mammary glands, directly stimulates the expression of progesterone receptors. This priming effect of estrogen receptors alpha is crucial for progesterone's subsequent actions, as it creates a larger pool of progesterone receptors available for binding. Unlike estrogen receptors alpha, estrogen receptors beta exhibits a broader tissue distribution found in the brain, bones, blood vessels, and other organs. Its effects on progesterone receptors are more context-dependent and vary across tissues. In some cases, estrogen receptors beta can synergize with estrogen receptors alpha to enhance progesterone receptor expression and activity. In others, it might act antagonistically. Estrogen plays a causative role in endometriosis formation. Endometriotic implants show estrogen dependence. Endometriotic implants express aromatase and 17-beta-hydroxysteroid dehydrogenase type 1, which are the enzymes responsible for conversion of androstenedione to estradiol. Endometriotic implants, however, are deficient in 17-beta-hydroxysteroid dehydrogenase type 2, which inactivates estrogen. Endometriotic implants also show progesterone resistance, which is thought to stem from an overall low concentration of progesterone receptors within implants. Specifically, pathologic overexpression of estrogen receptor C in endometriosis suppresses estrogen receptor I expression. This diminishes estradiol-mediated induction of the progesterone receptor in endometriotic cells, which bolsters survival of refluxed endometrium. Progesterone resistance may also enhance ectopic tissue implantation, secondary to augmented matrix metalloproteinases activity, which is necessary for implant invasion.